The atomic theory has been a popular theory founded in the early 19th century, and it is a widely expanding theory. To understand how atoms work, we need to examine their structures, their components, and how they form reactions. All this in the next few minutes. Let's assume you have a piece of yam or any fruit with you. Take a piece of knife and keep cutting it until it becomes the teeny tiny little bit of particles you can see. If you take a tiny piece, you are likely to see that it is still divisible over and over again. But even if you keep dividing, you are only dividing a molecule. In the molecule, we can find a group of atoms bounded by a bond and being held together by unseen forces. These are the real components of every substance you are seeing at the moment, just that we can't see them. Atom from the Greek word atomos, meaning in cut, from the famous atomic theory proposed by John Dalton in 1808, we have majorly 5 laws which gives us the behaviors of an atoms. The first rule states that matter is composed of exceedingly small particles called atoms. An atom is the smallest unit of an element that can participate in a chemical change. The second rule states that an element consists of only one type of atom, which has a mass that is characteristics of the element and is the same for all atoms of that element. This means that within a matter it only has the same atoms with the same properties. For example, Mercury has the same atoms all through and have different atomic masses from the rest of metallic elements, and it is the same rule for all. The third rule states that atoms of one element differ in properties from atoms of all other elements. For example, some metals are known to participate while some other metals don't participate. This proves that every atom of every element is different, and they react differently. The fourth rule states that a compound consists of atoms of 2 or more elements combined in a small whole number ratio. The fifth rule states that atoms are neither created nor destroyed during a chemical change. But as of the 20th century, most of this theory have been disputed and have not been proven to be correct under all circumstances, and here is why. Under the first rule, we have been able to divide atoms in a process known as nuclear fission. We have discovered isotopes of elements, and this proves that they don't have the same mass. But the atomic theory perfectly explains the law of constant composition and the law of multiple proportions. If an atom is examined well, if splitted, we get 2 major components, known as the electron and the nucleus. In the nucleus we have the proton and the neutron, and each have their different properties and mode of operation. All atoms have electron, proton and neutron, except hydrogen, which doesn't have neutron but has the rest. Most of the total mass of an atom is composed in the nucleus, which carries a whopping 99.94% of an atom's mass. The electrons are found outside the nucleus, and they carry a negative charge. The proton are known to be found in the nucleus, and they carry a positive electric charge. The neutron are found in the nucleus, and have no electric charge. If the proton and neutron in an atom are equal, then the atom is electrically neutral. But if not, that leads to atoms such as ions, which might have an overall negative or positive charge respectively. The number of protons in the nucleus of an atom determines the atomic number. The number of neutrons determines the isotope of an element. Based on disproving the first rule, let's learn about the discovery of the atomic components. Firstly, let's deal with the discovery of electrons. Electrons was discovered by J. Thomson in 1897 when he was studying the properties of cathode ray. He constructed a glass tube which didn't contain much air in it. Then he applied electrical voltage between two electrodes at either end of the tube. Then he discovered a stream of particles was coming out of the negatively charged electrode to positively charged electrode. This ray was called cathode ray, and the entire device was known as a cathode ray tube. The properties of a cathode ray: they travel in straight line. They are independent of the material composition of the cathode. Application of electric field deflects the ray towards a positively charged plate, hence cathode rays are negatively charged particles. A cathode ray particle is 2,000 times lighter than hydrogen. The charge of an electron was later verified by Robert Millikan in an experiment known as the oil drop experiment, and was determined to be 1.60 times 10 raised to power minus 19 coulombs. As of the present, the mass of an electron is 9.1 times 10 raised to power minus 28. Electrons' charge to mass ratio is minus 1.76 times 10 raised to power 8. Discovery of protons. Protons was discovered by Ernest Rutherford in the 1909. He bombarded alpha particles on an ultra-thin gold foil and then detected the scattered alpha particles on the zinc sulfide. From his observation, the alpha particles were not deflected. They passed through the foil, although very few bounced back. Then Rutherford proposed the theory of his atomic structure, which included protons as being a positively charged particle within the atom. Discovery of neutrons. The existence of neutrons has been a puzzling question for scientists who noted the model of the atoms and tried to fill us the question of the missing masses. There were various theories, but in 1932, James Chadwick used beryllium and bombarded it with alpha particles. He discovered the existence of a new particle which is chargeless and has similar mass to proton. He discovered neutron. Until now, we still keep adding to our knowledge of the basic building blocks of the things we see around us. We have many more unexplored particles out there to talk about. Exploring the quantum physics behind calculating the positions of an atom at an instance. So much to learn. The basics of all we need to know about plant life, its components, everything that puts them into the categories of living organisms. Up next on Science-y.
It's the best time to answer the most daring questions. Let's do this again together, this June. Brand new episodes of Interrogar to stream in June, only on Pyrashare Studios.